All right, so we have been doing systems of linear equations with two variables over the past few days. Now we're going to turn it up a notch, and we are going to learn how to solve systems of linear equations that have three variables in them, okay? So there are two methods to do this. You know both of them already. They are elimination and substitution. This video is going to be on elimination. So we have three different equations here, so I'm going to mark them as one. That's equation 1, 2, and 3. Okay? So our goal, when we start off with, if we're doing elimination, we want to get rid of one of the variables. So we want to eliminate either x or y or z from all these equations. Okay? So we're going to start off by doing that by pairing. We're going to just break it down into two pairs. So there's three equations here, and if I want to get rid of x looks like it's going to be the easiest, or z, because I can just multiply by 2 and by 4 here to get rid of them. So what I'm going to do is start by picking a pair of equations. So I'm just going to ignore the third equation right now, and I'm going to try and eliminate x from this set of three equations. So what I'm going to do is that I'm going to say I have x minus 2y plus z equals 15. And then my second equation is 2x plus 3y minus 3z equals 1. Okay? So we want to break this down into smaller pieces into what you already know how to do. So you already know how to eliminate a variable using when there's two equations. So what I'm going to do here to get rid of my x is I'm going to multiply everything by 2, like you guys know how to do. And so I'm going to get, if I simplify this, I'm going to slide this down. So this is equal to 2x minus 4y plus 2z equals 30. So this, after I've multiplied, gives me this equation. Now I'm going to rewrite that bottom equation so I can keep them in order. 2x plus 3y minus 3z equals 1. Okay? So now let's get rid of my two x's here. I'm going to subtract this bottom equation from the top equation. So if I do that, I have 2x minus 2x equals 0x. A negative 4y minus 3y is going to be a negative 7y. 2z minus a negative 3z is really 2 plus 3z, so that's going to be 5z. And then I have 30 minus 1 equals 29. So if I simplify this, I really have negative 7y plus 5z equals 29. So I've simplified and gotten rid of x from this pair of equations here. I'm going to do the same process now, but with 1 and 3. So I want to do it with 1 and 2 and 1 and 3. Okay, so I'm going to write my equation down here. I have, I'll do it up here, x minus 2y plus z equals 15. And then I need to make it look like 4x plus 10y minus 5z equals negative 3. So I can see that I'm going to have to multiply to get rid of my x. I need to multiply by 4 here, or negative 4 if you prefer the other way, it doesn't matter. So this needs to be 4, so this is going to become 4x minus 8y plus 4z equals 4 times 15 is 60. Okay? So now that I'm here, I'm going to do the same exact process, just like elimination that you know how to do. You just have a z hanging out in here. Functions the same way. So I'm going to subtract the bottom equation from the top equation. I have 4x minus 4x is 0, like we wanted to. Negative 8y minus 10y is going to be negative 18y. And then 4z minus a negative 5z is really 4z plus 5z. So that's going to be plus 9z overall. And then 60 minus a negative 3 is 60 plus 3, or 63. Okay? So now if I simplify this again, I have this equation right here. I have this equation right here, and they are in two variables. Let me make sure that you guys can see all that. You can. Okay. So now I have two equations and two variables, which gets us back to exactly, exactly what we know how to do and what we've been doing over the past 2 days. So I'm going to move this equation over here, and I'm going to say that I have negative 18y plus 9z equals 63, and I have another equation that's negative 7y plus 5z equals 29. Okay? So now, once we get to here, we can either use elimination or substitution. I'm going to continue with elimination, and hopefully the numbers will be a little bit kinder to me. So I'm going to decide that, let's see, I'm going to try and eliminate my z's here. Okay, so I'm going to multiply this top one by 5. I'm going to multiply this bottom one by 9 to get them equal to each other. 9 and 5 together make 45. So if I do that, 5 times negative 18, well, you can use a calculator. 5 times negative 18 is negative 90y plus 45z equals 5 times 63. Use a calculator. It should be 315 if my math is correct. And then I'm going to do the same thing over here. Negative 63y, 9 times negative 7, plus 45z. And now 9 times 29 should be 180 plus 81, which should be 261. Okay? I'm going to, since I want to get rid of 45z, I'm going to subtract from everything. So I have a negative 90y minus a negative 63y is negative 90y plus 63y. So that is going to give me a negative 27y. 45z minus 45z is just 0, so I'm going to leave that empty. And then 315 minus 261 is going to give me 54. If I divide by negative 27 on both sides to get y by itself, I'm going to end up with y equals negative 2. Okay? Now that I've found one variable, I need to go back to an equation where I have y and just one other variable. If I tried plugging it in here, it wouldn't help me because I don't know the two other variables. So I'm going to go back to this equation that we found earlier. Negative 7y plus 5z equals 29. And I'm going to plug now y into this equation. So I end up with negative 7 times negative 2 plus 5z equals 29. Negative 7 times negative 2 is a positive 14 plus 5z equals 29. I can subtract 14z from 14 from both sides, so I get 5z equals 15. And then if I divide by 5, I end up with z equals 3. So now I know y, I know z, which means I can go back to one of these original equations to figure out what our final variable x is. Okay? So I'm going to go back to this first equation over here, and I know that it's x minus 2, y is negative 2, plugging that in there, z is 3 plus 3 equals 15. You could plug these numbers back into any of them. This one looks the easiest to me. So we get here, we're going to simplify x. A negative 2 times negative 2 is going to be a positive 4. And then I have a plus 3 equals 15. Simplify that, x plus 7 equals 15. If I subtract 7 from both sides to get x by itself, I end up with x equals 8. So now I've solved for all three variables. So what we have here now is called, you guys are used to when it's x and y, we call those ordered pairs. What you guys have just found is called an ordered triple, and it goes in the form like this, x, y, z, and they're plotted in 3D space instead of the xy plane. So what we have found is that the solution to our system of three variables, or the three equations, is 8, negative 2, 3. So there's a lot of work going on here. It's basically doing elimination twice, and just separating it, breaking it down into smaller problems. So this has been how to solve a system of linear equations in three variables.